Upload your doubts on the app to get video solutions.
A block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. Fine. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its own axis. Clear? So, this is the scenario. Pay attention. So, here what is happening is we have a block over here. Okay. On this block, what are the forces which are acting? One is weight of the block which is acting downward, correct? And because this is acting downward, this is on the inner wall of the cylinder. There is a normal reaction given by the wall of the cylinder, and that will be on the left hand side, and centrifugal force acting on the right hand side because of the rotational motion, right? Frictional force, that is the limiting friction here, upward in direction. So, this is FBD. Okay, if you want to draw again FBD, let's draw it over here for the block. Weight of the block downward, mg. Normal reaction provided by the inner wall of the cylinder. Frictional force, FL, and minus mr square omega. Mr square omega is centrifugal force, or m, you can say mr square, you can say centripetal acceleration, AC is omega square r, correct? Now, for equilibrium of the block, for equilibrium, the resultant must be 0, right? So, for equilibrium, the frictional force FL, limiting friction, must be greater or equal to the weight, right? Because if weight will be greater, the block will slide down and it will fall to the ground. So, FL, the limiting friction, must be equal to the weight. And what is FL? It is mu n, that must be greater than the weight mg. And what is n? From the FBD, free body diagram, we can see that n is nothing but mr omega square, right? They are equalized. So, that must be greater than mg. Or omega square will be greater than or equal to cancels. How much we left with? G upon mu r. Or let me write it in small only, r. This will be our omega square. So, what will be the angular speed of rotation? Omega must be root under G upon mu r. This will be our omega, correct? And what are the values of mu r and G given here? So, let's use this formula here only directly. Omega we got as root under G upon mu r. So, what is our G? G is 10. What is our mu? So, coefficient of friction is 0.1 and radius is 1 given in the question. So, this will be how much? It will be root under 100, and that is equal to 10 radians per second. So, correct answer is option C.
Watch the complete playlist on the app Pions. Download the app now.